Alright folks, so today we're going more into solving right triangles. We're going to talk about a couple different terms that are used in word problems when solving right triangles, because today's lesson is going to be oriented more towards word problems than just pure triangle with numbers. So what we're going to talk about, we're going to talk about how you would define an angle of elevation and angle of depression. We're also going to talk about the bearing of a line. So angle of elevation, pretty simple definition. It's an angle measure that's measured from the horizontal up. Depression, horizontal down. It makes sense, elevation meaning that you're elevating to go up. Depression means it's going down. So in this case, if you're looking at this example, B here, or beta, that's an angle of elevation. Alpha here, that's an angle of depression. This is being measured starting at the horizontal and going down. So here, favorite classic example here, we have a squirrel named Squirrelo, and this is actually based off a squirrel who my friends kept as a pet in high school. Kind of weird children anyways. But he sits 120 meters away from Lafayette and looks up an angle of elevation of 25 degrees at a hawk named Falco. Hopefully you get the reference. Perched atop the school. How tall is this school? Okay, so we have the ground here. We'll make Squirrelo red. I know that's a fancy looking squirrel. Ooh, we gotta give him a better head. There we go. He's got a little arm there. Okay, a Squirrelo. Big Lafayette. And of course, if you get the reference, Falco has to be blue. There's some wings. It's a pretty picture. I'll say so myself. So, once again, we know that this distance from the horizontal to the school, we are told that equals 120 meters. 120 meters. And we're also given angle of elevation up to Falco, which is elevate. Since it's an angle of elevation, that means it has to go from a horizontal line up, and it's saying the angle of elevation is relevant to Squirrelo because he's the one looking up with it. So the angle of elevation is going to go there, and that should end up equaling what we're given as 25 degrees. So put 25 degrees here. How tall is the school? So what we're trying to find is this overall height. So if we're looking at this, we're given, oops, I wrote that wrong. This is 25, sorry guys. 25, okay. So what we're looking at, we have this value, and we know that side length value, because that side length value, 120. What we need to find is that height. So from the 25 degrees, that's an adjacent side, that's an opposite side. So we're going to use tangent. So we're going to have tangent 25 degrees equals h over 120. So then to solve that, we'll multiply by 120 to both sides. And we'll find out what h equals here. So h will equal 120 times the tangent of 25. We'll go over that answer in classes. I happen not to have a calculator. But that's all you're really doing here for that type of problem. Okay? Take a second, write this example down. I said it's really nice if you actually write these notes down this time because it saves you time from having to write this down in class. So I'm trying to also go over the example. Alright, last part is bearings. So, bearings really aren't used a whole lot. They're really only in like nautical type stuff or, flight where, there aren't roads or pathways that you really have to follow. So, a bearing of a line is the acute, and that's a key term, acute angle measure, so it has to be less than 90, formed by the north-south line. So, the north-south line, if you're looking at example 1, is what I just highlighted in blue. So it's acute angle measure from the north-south line in the direction east or west. Okay, so what we're doing here is you'd start with your north-south line based upon what you're given. Like in that example, it's north, so I'm going to start my north line. and it's going to go followed by an angle measure. So I have 7 degrees in the eastern direction. So hopefully you remember, east, west, south, north. So this bearing here, starting from the north-south line, so north 70 degrees, which is from the north line out here to the east. So that's my line L. This is 70 degrees. So that's what the bearing will look like. And what's strange about bearings, and it kind of takes a little bit to wrap your mind around, is that you're measuring from the y-axis, which you almost never do in trigonometry. Everything is almost always exclusive from the x. But that's just how it is for these. So here, if we look at the next one, we're starting at the south line, which is down here, going in the west direction, 30 degrees. So this is 30 degrees. So our bearing is that line, L. I'll leave the third one for you to try on your own. Alright, last but not least, you and a friend decided to go drive from school to P.F. Chang's. You drive 6 miles east on Clayton Road, then 8 miles north on Clarkson. Given these directions, what is the bearing from Lafayette to P.F. Chang's? Same concept as what we just talked about, just now in a word problem format. So let's start at LHS down here. So you're trying to find the bearing from Lafayette to P.F. Chang's, which is up here. So what you're given is that you've traveled 6 miles this direction. Oops, I need to use something else for that. Let's go back. Let's use that. So you've gone 6 miles here. And then you go 8 miles north. Once again, I realize this isn't quite exact, but it gets the job done. So 8 miles north. Now your bearing from Lafayette to P.F. Chang's is that red line, and we need to know that angle measure. Because from that red line, it's easy to tell that this is north so many degrees to the east. So how you would find this angle measure? We can use trig to actually find what I've marked as theta, which is this angle there, by using an inverse tangent function. And then we know the overall angle here is 90 degrees, so we can subtract this from 90 and find the last part of our answer. So go ahead, give this a shot. I'd be curious to see what you come up with, because I kind of got you started here. Once again, what we're looking at is you have tangent of theta equals 8 over 6. So theta is going to equal the inverse tangent of 8 over 6. And then use that subtracted from 90 to actually find what goes there. Alright, that concludes today's notes. I hope this was informative and makes sense. If you have any questions, just make sure to ask me in class again. Have a good one, guys.